Welcome to video 4.4H, one more proof with the equidistance theorem. All right, so here's example 8 and the last one in lesson 4.4. All right, so given this figure with the following, I'll mark it up as we go along. AB is congruent to BC, AE is congruent to EC, prove that AD is congruent to DC. Now, let me tell you the way that most students would approach this problem, and then I'll show you a shortcut by just thinking of the equidistance theorem. All right, so most students would say, hey, if I can get this triangle congruent to this triangle, then I can use CPCTC to get those parts. And to get this triangle congruent to this triangle, you would first want to get this triangle congruent to this triangle. You can get this triangle to this triangle, you can use reflexive there by SSS. Once these triangles are congruent, you can get these angles congruent by CPCTC. Once these angles are congruent, then you can get those angles inside the triangles you care about. If angles are supplementary to congruent angles, then those angles are congruent. So that's how you could ultimately get these angles here congruent. Then you would have this side, this angle, reflexive this side, to side, angle, reflexive side, and you'd have a bunch of steps in your proof. But let's think a little bit differently. Let's think of equal distance from the endpoints of a segment. Well, I don't really have this segment, but I can draw it. Let's draw in AC. We can do that. Auxiliary line, Euclid's postulate says you can connect a line through any 2 points. Oh, point B is now equidistant to those endpoints. Point E is now equidistant to those endpoints. So that means this is a perpendicular bisector of AC, which then means every point on that perpendicular bisector is also equidistant to the endpoints A and C, which is exactly what I'm trying to do. So fewer steps, okay? So I'm gonna do the proof that way. So here I go, no triangle congruence whatsoever. Step 1, I'll just say AB is congruent to BC given. That's one of my equidistant points. I probably should have drawn in the auxiliary line first. Let me do that first. Sorry about that. I'm going to say draw AC. Auxiliary line. I always like to do the auxiliary lines in step 1 just so that the reader can see what's going on. Then I'll do AB is congruent to BC, given, that was one of my equidistant points. AE is congruent to EC, that was given. That's another equidistant point. Once I get that, then I can go to perpendicular bisector. So I can say BE, perpendicular bisector of, I'll just say line BE, of AC. If kite thing, then perpendicular bisector thing. And now once I've established that point D is in fact on that perpendicular bisector, he will be equidistant. I'm done. AD is congruent to DC if perpendicular bisector thing, then equidistant. So just a little shortcut, and I'm sure this will be used in quizzes and tests, the final exam, this kind of thought process. So there you have it. One more proof with the equidistance theorem, used both in the original context and the converse.